Okay, let's look at another example involving mathematical induction, this time with divisibility. So we're asked to prove by mathematical induction that 7 raised to the 8n plus 3 power plus 2, where n is a natural number, is divisible by 5. Another way that we could write this notation is to say prove that 5 divides 7 raised to the 8n plus 3 power plus 2 by mathematical induction for n greater than or equal to 0, right? For our purposes, right, our natural numbers, right, our natural numbers, you might write it like this also, is going to be greater than or equal to 0. In many American universities, natural numbers will start at 1. Um, so you want to be careful about how you define things. And for our purposes, we're going to say natural numbers are going to be greater than or equal to 0. So let's do this work. Our first step is to consider our first case. So if I have n equals 0, so that's going to be 7 to the third power plus 2. All right. And if I look at 7 to the third power plus 2, I can use a calculator to help me out there if I need. Or I could know that 7 to the third power is 343 plus 2, which is equal to 5 times some value, right? And where that value is going to be some integer. So therefore, our basis case is true because 7 to the third power plus 2 is divisible by 5. Okay. Then our inductive hypothesis. We're going to assume true for our kth case. We're going to assume P of k is true. Our propositional function we're going to assume is true. Then consider n equals k plus 1. All right, that's going to be 7 to the 8th power k plus 1 plus 3 plus 2. All right, rearranging, that's going to be 7 to the 8k plus 8 plus 3 plus 2. All right, now let's make this a side so that we can see it more easily. Assume that 5 divides 7 to the 8k plus 3 plus 2. So therefore, 7 to the 8k plus 3 plus 2 is going to be 5 times some particular integer, right? And we can say where k and a are going to be integers. And actually, we should just say where a is an integer, right? And we were working with natural numbers. All right, so giving you different ways to write natural numbers. Right, so k being an element of, let's rewrite that a little bit better. So k being an element of natural numbers. Okay, so with that we can come over and rewrite our k plus 1th case to say 7 to the 8th times 7 to the 8k plus 3 plus 2. But really this is 7 to the 8th times, right? Well, 7 to the 8k plus 3, I can say is 5a minus 2. And then I have plus 2. which really this is 5a times 7 to the 8th minus 2 times 7 to the 8th plus 2, which is 5a times 7 to the 8th minus 2 times 7 to the 8th minus 1. All right. Now, with the calculator, I would imagine, I don't think many people are comfortable doing 7 to the 8th in their head. All right, but 7 to the 8th is, and we're not going to expand here, but 7 to the 8th with a calculator is 5,000, excuse me, 5,764,801, and then minus 1. So that's 5a times 7 to the 8th minus 2 times 5,764,800, which then really is just 5 times, all right, some number a, 7 to the 8th power, minus 2 times some other number. All right, so therefore, we're true for n equals k plus 1, right? Our k plus 1th case is also going to be divisible by 5. So all that's left to do is to write our conclusion. Oops, can't spell here. Because, all right, our first case is true, and when our kth case is true, it follows that our k plus 1 case is true, all right, by the principle of mathematical induction. Our proposition is true for all natural numbers, because in this case, we're working with natural numbers. Okay, so quick review of our setup again. All right, we have our proposition. We look at the basis step. We do our inductive hypothesis. We consider the subsequent step, the k plus 1th case. We look to see how we can use our inductive hypothesis within our k plus 1th case. Go through, do the mathematics, and hopefully our proposition holds true. And if our proposition does hold true for our k plus 1th case, when our proposition is assumed to be true for our kth case, and we have shown that our proposition is true for our initial case, then by the principle of mathematical induction, our proposition must be true for all of our particular set of values, in this case, our natural numbers. Okay, so if you have additional questions about proof by induction, you do get better by trying them. This was an example of divisibility, excuse me. Thank you very much for your time.